Hi everyone. In this lecture, we are going to start with the array. So let's start with the definition. An array is a collection of similar data items together in a contiguous memory location. So first of all, array is a linear data structure where we will keep similar data items together, okay, and they will be in contiguous memory locations. The memory allocation will be contiguous in the RAM. So how can we access the elements of array? If you want to access the elements of the array, we can use the index, right? Let's take one example. Let's take first example. Here we have initialized array. So this is basically we called array initialization. And this is called array declaration because we are declaring the array of size 10 here. And here we are initializing array with some values. That's why it is called array initialization also. Now, let's suppose we want to access some element. Let's suppose we want to access 75. So by the index, this will be the index number 2 because it will start from 0, 1, and this index will be referred as a 2. So if you want to print the value of 75, then a of 2 we have to print. Okay. And the third example, you can see this is another way to initialize the array in which we are giving only two elements, 1, comma 2, and remaining three elements will be initialized as a 0 in the C language. So in this way, we can declare or initialize the one-dimensional array. Now, if you plot the first example, or if you see the representation of first array, then it will be like this 25, 50, 75. I can say that this is A of 0, A of 1, A of 2, A of 3. So by default, this way, size will be automatically initialized to 4. Next is advantages of the array. If you use arrays, then accessing the element will be very easy, like we have done using the index number. You want to access any number, you can write A and the index of that particular number, you can easily access the number. Then the searching process. The searching process also can be applied very easy on the array. We will see how we can do search in the upcoming videos. Then another operation which is called sorting, that is also very easy to do in the arrays. That also we will perform in the some classes. 2D array. We use 2D arrays for the representation of the data in tabular form, we can say. So that's basically called matrix. So if you want to represent your data in the form of matrices, then we will use the two-dimensional array. Then we have multiple uses of the arrays, as we can implement stack, queue, graph, tree, and many other data structures with the help of array. So it will help in creating other kind of data structures. Then next is passing to the functions. Means that if you want to pass the arrays as a function, okay, let's suppose I want to pass this array as a function where we have some elements inside the array. Then this way you can pass that. So at the time of calling this as an actual parameter, I am passing this array, and this actual parameter will be copied into the formal parameter where the function is defined. So this is another advantage or use of the array. Then we have some limitations of the array. Uh, the first one is the size will be fixed. Let's suppose if I want to define some array like this int of a of 5, now When you run it, the size cannot be changed after running. So int a of 5 I have declared the size will be fixed. So if you want to change it at runtime, it is not possible in case of arrays because these data structures are called as static data structure. And static data structures will not change at runtime. Now, since we cannot change the memory at runtime, usually we declare the size of the array is very high so that we will not change it and it will be enough to store many elements. So in that case, if you want to use only fewer elements out of 100, or maybe let's suppose you are using 20, 30, or 40 elements, then remaining will be wastage. That's why if you define the big size of array, then memory will become useless. So that will be called memory wastage. Next is limitation of types of data. So as I told you, it stores a similar data items, okay, or similar type of data. It means we cannot store multiple type of data inside one array. And for that purpose, we have to use some other kind of data structures or maybe some other type of things like in C++ we use class or in C language also we use structure. So with the help of these user-defined data types, we can store different types of data. But array can only store similar type of data and single type of data. Insertion and deletion is difficult or inefficient. So these insertion deletion operation you will see in the next video probably. So there you will see that insertion and deletion is not very suitable option if we use array. So these are some limitations of the array. Next is the two-dimensional array. In two-dimensional array, as I told you, if you want to store the elements in the form of table, then we can use multi-dimensional or specifically we can use two-dimensional array. So this is the one two-dimensional array we have initialized where we have six values. So it is a 2 by 3 array means we have total of six elements in which this will represent the rows and this will represent the columns. So we have two number of rows and three number of columns. So obviously our data elements will look like this. If I tell you what are the indexes in this, then this will be a of 0, 0, which is 1, and next will be a of 0, 1, next will be a of 0, 2. Second row will start with 1, a of 1, 0, a of 1, 1, a of 1. So in this way, we can represent them in the form of matrix. Okay. So this matrix is actually your row measure order, the row measure order representation. So basically, for representation of array, we can have two types of representation. One is row measure order representation, and another one is the column measure order representation. Now, if you want to print this 2D array in the C language, then how we can print that? Okay, so we have two loops here. One loop is, we can say, outer loop, which is running from 0 to 1, because it is I less than 2. So it will run for two times. Means this loop I am representing for row, and it will be your outer loop. And next loop is j is equal to 0 to, you can say j is equal to 2. This j less than 3. So it means this loop I am using as for column purpose. So this will be your inner loop And in C language, if you want to print all the elements, then I will use like this statement. Then it will print all the elements of the 2D. So in this way, we can use row measure order representation, which is usually used by most of the programming languages like C, C++, and Java. So if you want to see the definition, in the row measure order, elements of an array are stored in row-wise fashion. As you can see, we are reading all the elements like this 1, 4, first row, then we are studying 3, 6, 8, second row. Row-wise, if we read the elements, then we can say that is row measure order. Even the memory addresses will be assigned like this only. So it will print 1, 4, 2, 3, 6, and memory addresses will be also assigned like this only. So this is called row measure order representation. Next, next is column measure order representation. So as you can easily understand that in this kind of representation, we have to read the elements using columns. So first, I will read first column, then I will read second column, then I will read third column. So let's suppose example is same example we will take. Okay. So in this example, you can see that we will print one first, then after that we will print three. Then we come to second column, we will print four and six. Then we come to third column, two and so in this way elements will be printed. So this is called column measure order. This is usually uh, used in the MATLAB or Fortran language. So what the loops will be applied? If you want to print these elements like this, then in the C language, what loop we will apply so that it will print this 1, 3, 4, 6 to 8 like a column measure order. Okay, so this loop we will apply for printing the elements into the column measure order. So let's suppose try this. Let's suppose I want to run for I is equal to 0. And the inner loop will run for two times for j is equal to 0 and j is equal to 1. So it will print in the form of ji. So ji means it will print 0, 0 first, then it will be 1, 0. So 0, 0 means basically you are printing first element. Then second elements we are printing now a of 1, 0. So it will be 1 and 3 first. Then for I is equal to 1, this loop will again run. So j is equal to 0 and j is equal to 1. So it will print a of 1, 0, sorry, 0, 1, and a of 1, 1. It will print 4 and 6. Then for printing 2 and add, again for I is equal to 2, it will run. So you can see the outer loop is running, then inner loop is running for every I. So it will run for j is equal to 0 and j is equal to 1. So it will print 0, 2 first, then it will print 1, 2 as we have j, ji. So in this way, column measure order will be represented using C language like this. Okay, so in the row measure order representation, here I made one mistake that I have written A of I earlier. Now it is A of ij I have corrected. So this is called row measure order, and the next one that is called column measure order. Now, in the next lecture, we are going to study about the how we can calculate the memory locations address in the 1D array and 2D array.